Friends, welcome to my YouTube channels, my YouTube Dr. Ashok G Make Solution. So today I'm going to discuss the one friction problems. Already basic concept, basic problems already we discussed previous video. Now I'm going to discuss these problems what I wrote in the board. What is that? A body resting on a rough horizontal surface. Rough horizontal surface on body is resting and given the pull force of 18 kg at angle of 30 degree to remove the plane. Now it was found that a push of 22 kg inclined at same 30 degree, then to remove the body. So then in that case they are asking what is the W and what is the coefficient of friction. So these two they are asking. If both will combine together, will solve, will get the solutions. Now look here. So what I did here. The given question, this is the diagram, this is given question, this is the diagram. We draw the here free body diagram. Now again I will discuss these two free body diagrams separately. So case 1 first. So what is there here? One body given the 18 kg pull force at an angle of 30 degree. Weight always will act vertically downward. If weight is acting vertically downward, these normal reactions will be always there. So see this example. Why normal reaction? Suppose this is the body, weight acting downward. But who is giving reaction? Hand is giving reaction. That's why body is the static condition. So reaction force acting in the bottom and weight is acting downward. So weight is acting downward, reaction force acting upward. So this is the balance. Now, inclined force. Inclined force, how to resolve? See here. This is the rough surface, rough horizontal surface. How to resolve that? You see, inclined force having two components. So, according to this, inclined force, 30 degree 18 kg. Now, body wants to move along the plane. Body wants to move along this plane. Once you know how body wants to move along the plane, but body moving some inclined 30 degree. So this first body moves along this direction. This is the first resolution, 18 cos 30. Then for this force, mutually perpendicular will be there, 18 sin 30. So first resolution what is 18 cos 30. Why cos? Because how will remember, if near angle, always cos component. This with respect to horizontal, this is far. So this is the sine component. This will be 90 minus 30. 90 minus 30. This is 30. This is 90 minus 30. This angle will be 90 minus 30. This is 90 degree. Okay. So that things don't go deep. Near angle cos component, far angle sine component. So this we did here. Are normal forces, 18 cos 30, 18 sin 30. Now, body is moving this direction, but this problem is in static condition. Body is not in static condition. So, body moving this, so frictional force will act the opposite of the forces. So, frictional force is given. Similarly, you see the drag forces, push forces. Again, rough horizontal surface is there. Now, push forces will be this direction. This is 22 kg. This is the 30 degree. How to resolve? So once body is pushing this way, so first we will draw this horizontal line. So this angle equal to this angle. See, two parallel line. It will be two parallel line. If we will cut this one inclined line, this alternate angle will be equal. Alternate angle will be equal. So this angle equal to this angle. So this is the near angle now. So what is this one? 22 cos 30. Then mutually perpendicular this one. With respect to this horizontal perpendicular, this is called 22 sin 30. So this is the push force ka resolution. Now weight vertically downward, na normal reactions will be upward. Now frictional force where will apply? This force, horizontal force moving the right side, so left side. Now frictional force will be opposite to the balance of this body. So this will come the static condition. Now frictional force will be this way. So frictional force this 22 cos 30, 22 sin 30. Now if you know this free body diagram, for this free body diagram is this and this free body diagram this. Now we'll apply the two equilibrium equations, we'll get the answer. So we'll apply the two equilibrium equations. What are the equilibrium equations here? See here, case 1. Case 1, these things will have it. So this is the case 1. What is the case 1? First equilibrium equation, sigma h equal to 0. So what we'll do there here? Total rightward force equal to total for me leftward force equal to total rightward force. So this was what is F. Now this force how much? 18 cos 30. Now F equal to mu R equal to 18 cos 30. 18 cos 30, how much is there? 18 cos 30, 15.6. So 15.6 kg. Give equations number 1. Now we'll go the another equilibrium equation, sigma Fb equal to 0. So total, here what will be the concept? Total upward force equal to total downward force. Always you assume this concept, so it will not get confused. Actually negative positive is there. Suppose downward force is negative, upward force is positive, or upward force for negative, this positive, you assume. But no need to assume this. What you do? Total upward is equal to total downward. Total rightward is equal to total leftward. So that way it will be easy for you. So R plus 18 sin 30 is going upward direction. So you write here itself R plus 18 sin 30 equal to W. Now R is equal to 13 and 9. W this side will go there, W minus 9. So now substitute these equations 1. Substitute R in equation. Substitute R in equation 1. So what will get? Mu W minus 9 is equal to 15.6 kg. Give equations 2. Now case 2. Case 2 what will write here? Case 2. Sigma Fh equal to 0. That means total this direction is equal to total this direction. That means rightward equal to leftward taken. So F equal to 22 cos 30. So mu R is equal to 22 cos 30. How much? 22 cos 30, 19.05. It is coming 19.05. Give the equations number 3. Equations number 3. Now look here. Sigma Fb equal to 0. Case 2. Sigma Fb equal to 0 na. Total upward force equal to total downward force. What is there? R equal to W plus 22 sin 30. Sin 30 half na 11. So R is equal to, or you can write here W plus 11. Now this substitute, R substitute in equation 3. So mu is equal to W plus 11. W plus 11 is equal to 19.05. Give equations number 4. Give equations number 4. Now we'll solve. Divide equations 4 by equations 2. Equations 4 what is? Mu W plus 11 is equal to W plus 11 mu W minus 9 is equal to, this is 19.05, this is 15.06. If you go the cross multiplication, so first mu will get cancelled. So cross multiplications you will get. So you will get here W is equal to 99 kg and mu, substitute the mu value in the equation 3 or 4. Okay, just to wait one more steps will go through here. So what is there? 19.05. So it will be easy for you. So W plus 11 by W minus 9 is equal to 19.05 divided by 15.06. It is coming 19.05, 15.6 only. 15.6. Again we will check it here. 19.05 divided by 15.6, 1.22. So 1.22 divided by 1. So go the cross multiplication. What is? W plus 11 into 1 is equal to W minus 9, 1.22. So you will get W is equal to 99 kg. Now W value you substitute in the equations either 2 or 4. So you will get mu W is equal to 99 minus 9 equal to 15.6. So mu is equal to 15.6 by 90. So how much coming? 15.6 divided by 90. So getting point 0.173. This is the mu value. So this way we can get the answer. So we got the W is equal to 99 kg. This is answer. And mu is equal to, you got the 173. This is the answer. So this way we can solve these questions. Okay. Okay, friends. Thank you. Watch this video. Subscribe the channel. Share this video to your friends so they can get the maximum benefit for that. Okay. Thank you.